Suppose we want to evaluate the following integral. The integral of 3x squared times sine of x cubed dx. To apply the substitution method, the first step is to determine an expression for a variable called u. So let's say u is equal to x cubed. Notice that x cubed is in the argument of the sine function. Then we can differentiate u with respect to x. When we do that, we get du dx equals 3x squared. Notice that 3x squared appears in the integrand. This is very convenient. Now let's multiply both sides of this equation by dx. Once we do that, we get du equals 3x squared dx. Now, this multiplication of both sides by the dummy variable dx is not mathematically rigorous, but it works for the case of the substitution method. All right, so now we have an expression for u, which is x cubed, and an expression for du. We need also an expression for dx. So let's solve for dx in terms of du, or alternatively, we can realize that 3x squared times dx is exactly this expression on the right. So du is actually already in the integrand. So let's use that technique and rewrite the integral as du, and I'm going to underline what I have substituted. So du has been replaced, 3x squared dx has been replaced by du, and we can multiply du by this sine function of u, because u is equal to x cubed. All right, I'm going to remove that underline here. Now we just need to evaluate the integral with respect to u. Notice that this is an indefinite integral. The derivative of cosine is sine, so we will end up with a cosine when we evaluate this integral. In particular, we will get cosine of u plus c, because the c is an integration constant and it's necessary to include for our indefinite integral. All right, I just made a silly mistake. The derivative of cosine is negative sign, so I need to put a negative sign here. Apologize if that caused any confusion. So our final answer is going to include x because the original integral was given in terms of x. So we have negative cosine of x squared, x cubed, I misspoke, plus c. And that's really it. So it was quite an easy integral to evaluate. In this case, if you notice that the substitution method was applicable to this particular integral. All right, I hope this video helped you understand the substitution method for integration. Thanks for watching.